All right, so we're continuing our journey of exploring why the numerals have the distinctive shapes that they do, and in this video we're going to look at the numeral that represents the number 4. So we're going to do the same procedure that we've been doing with all the numerals. We're going to go to the corresponding ring in this diagram. We've discovered that all of the numerals are connected to rings in this diagram that correspond to their value. So we're going to go to the 4th ring in this diagram. That's going to be the ring that has the radius of the square root of 4. And we're going to look for the specific points that define that radius. So we know that the square root of 4 is 2, so we just have to go over 1, 2, and that's the point that defines the square root of 4. It's an actual lattice point, so we can see that there's that point, this point, and that point. So we're going to create a symbol that touches down on at least some of those lattice points, and actually we know what the 4 looks like. We're going to start at this top point here, and we're going to draw a line right across the diameter of that circle, because that's the length of 4. Because that's another aspect to all the numerals. They all contain the value of the number that they represent. So there's our 4 right there. Now the next thing that we're going to do is draw a straight line from there going down to this point here, which is also a point where the square root of 4 is intersecting, but here it's where the y is -1. So that point there, and that's directly below this point here, which is the square root of 3 circle. So we go straight down, we go from the square root of 3 to the square root of 4. So that's the special right triangle in there. So in this shape, there's a lot of these special right triangles kind of built within the shape. You know, we got this one right here. There's the special right triangle finding that point, and basically that whole angle is the special right triangle. So from up here we go down 3 and over the square root of 3, and that's that triangle right there. This triangle has the proportions of 1, 2, and the square root of 3. That side's 1, this side's 2, this side's the length of square root of 3. So what we're basically doing is multiplying all these sides by the square root of 3. So we get 3, 2 root 3, and the length of the square root of 3. So what's interesting about this line here is the distance from the end here, square root of 3, as you go along to the 2, is the distance of 2 minus the square root of 3. That's the same length as the point here. You have this, here's the square root of 3, and the square root of 4, which is 2. So this distance here is 2 minus the square root of 3, 2 minus the square root of 3. And this point here, where this 15-degree angle off of this line here is also the length of 2 minus the square root of 3. So we're going to take that length of 2 and just slide it over, so where it's intersecting that point where this line comes down and it's hitting this point here. So what I'm going to do is just get my clear board and put it up here so you can see what that all looks like. Draw it out for you, or basically trace it out for you. So we got our first lattice point right there, and then we're going to go right across 1, 2, 3, 4, the whole circle. So again, that's our length of 4. I'm just going to draw this freehand. I'm going to draw a line going across here like that to this point here. That's our length of 2 root 3, and this is our length of the square root of 3 to there. There's our triangle. Then we're going to extend that a little bit more, because we know the 4 actually does cross that line. That's part of the design of the numeral, and it stops right there. So now we have the length of 1, the length of 2, the length of 3, and then the overall length of 4, the length of 2 root 3, and the length of square root of 3, all contained within that symbol that represents the number 4. Because there's a lot of relationships between 3 and 4, and if you're progressing through the numerals, this one's sort of summing up where we are so far. We've created all those lengths and numbers, or lengths and values in the different symbols. So I'll just put the whiteboard behind, and you can see what that looks like. That's the correct proportions for the numeral that represents the number 4. So someone very wise in the ways of geometry, and they knew their math, they came up with that design to represent the number 4. So that's it for this one. Thanks for watching.